After studying this module, you shall be able to understand clearly the concept of production, what are production functions, the difference between short run and long run production functions, the concept of total product, average product and marginal product and the relationship among them, law of diminishing marginal product. In the previous modules, we discussed in detail the theory of consumer preferences, consumer behavior, law of demand, price elasticity, demand estimation and so on. In short, we studied how consumers decide what goods to purchase. In the next few modules, we will study where the supply of these goods come from and how the supply decisions are taken by firms. For this, firms essentially look at three things. A. What they are able to produce. B. What is the lowest possible cost of production and how it can be achieved. And C. How to maximize their profits. In the present module, we cover the first part, that is, we focus on what firms are able to produce. This deals with the fundamentals of the theory of production in the short run as well as in the long run. In a market economy, most of the goods are produced by privately owned firms whose owners earn profits from the sale of the output they produce. Firms use certain inputs in order to produce output. Among these, some inputs are fixed in quantity while some are variable inputs. In a short run situation, a firm has a fixed amount of plant and machinery with which they produce the output. They change production levels by hiring more or less of variable inputs like labor, raw materials, while the size of the plant essentially remains unchanged in the long run. The owners determine how much of the inputs have to be increased or decreased and at what combination they are to be used with fixed inputs. The rationale behind these decisions can be understood using production theory. Next, we will discuss upon production theory. The concept of production. Production refers to the manufacturing of goods and services with the use of various resources such as labor, plant and machinery, land, raw materials, etc. For example, when a firm produces cars or when a bank produces financial services, the activity is called production. Hence, production includes making of goods as well as services, using various inputs or resources which people can buy and utilize. In this module, we will discuss production by business units which use inputs to produce goods that are sold in the market. For this, we need to know the relation between the inputs used and output produced. This relationship is given by a production function, a concept that is explained below. Production function. A production function is a relationship between the amount of inputs used and the output produced. It explains the link between the quantity of output produced and quantity of inputs used. It describes the maximum amount of output that can be obtained from a given level of inputs. Typically, a number of inputs are used in production. The maximum output produced can be expressed as a function of the level of various inputs. Let n inputs denoted by Z1 till Zn and output be denoted as Q, then we can express the relationship between Q and the Zi in the following equation. Q is a function of Z1, Z2 till Zn. For simplicity, we assume that there are main two inputs, labor and capital. So, the input-output relation can also be written as Q is a function of L and K, where L and K represent labor or man hours and capital or machine hours respectively used in the production of the good Q. This relation can also be represented in the form of schedule or table where the relation can be clearly seen. See the table 1 which shows a production function. It has units of capital and units of labor. The values in each cell of the above table shows the maximum output in red that can be produced from every possible combination of labor and capital. Note that with zero capital, no output can be produced regardless of the labor usage. Similarly, with zero labor, there can be no output. This demonstrates an important point, which both inputs are necessary for production. An important concept, namely technical efficiency, is embedded in the production function, which gives the value of the maximum output that can be produced for any given combination of inputs. In this sense, technical efficiency is always achieved by a given production function. Example, with reference to table 1, the maximum amount of output that can be produced using 6 units of labor and 4 units of capital is 523 units. However, the production function does not automatically imply economic efficiency. Economic efficiency is achieved when the firm is producing a given amount of output at the lowest possible cost. An economically efficient method of producing a given level of output depends inter alia on the prices of inputs. A production process may be technically efficient but not necessarily economically efficient. For instance, consider the following example. Suppose there are two different production processes, say first and second, and both are technically efficient. But process first might cost less than second at a given set of input prices. In this case, we say first is economically efficient at these set of prices, while process second turns out to be economically efficient at a different set of input prices. Next is a production function with variable inputs. To analyze the process of production, we classify inputs as variable inputs or fixed inputs. A. Fixed input. A fixed input is one for which the quantity used does not change with change in output. Moreover, such inputs must be paid for even if no output is being produced for some period of time. This category includes inputs like building, machinery, etc. that are necessary for undertaking production, but which cannot be rapidly augmented or reduced as the level of output changes. However, no input is permanently fixed. We assume certain inputs to be fixed in the short run, but in the long run, which is also a planning horizon, all inputs are variable. B. Variable input. A variable input is one for which the quantity used changes in response to changes in output. These category includes input like labor, raw materials, energy consumed during production, etc. Now we will discuss upon single variable input. Economics distinguish between the short run and the long run on the basis of use of inputs. The short run refers to that period of time in which one or more input is fixed. Hence, change in output is due to changes in variable inputs like number of labor hours, increase in quantity of raw material, etc. So, to increase output in the short run, a producer can use more labor units and other variable inputs with largely the same amount of plant and machinery, fixed inputs. He cannot quickly set up a new plant in order to increase production. That is a long-term decision. Therefore, capital, for example, heavy machinery, buildings, etc. is considered to be fixed in the short run, while labor is a variable input. The resulting production function may be written as Q is a function of L, K star, where K and L are greater than 0. Note, star signifies that the input is fixed. If the input is fixed in the short run, output depends only on the variable input, and hence we can write the production function simply as Q is a function of L. Next is the two variable inputs. Generally, in the longer run, both L, labor, and K, capital, may be considered as variable inputs. According to economists, the long run refers to a period of time that is long enough so that all inputs can be changed. This implies that all inputs are variable inputs in the long run, and the long run production function can be written as Q is a function of K and L. Actually, the long run consists of many short run states. A firm purchases a certain amount of capital in the short run and operates with that fixed amount in the short run. Capital stays fixed for some period short run, and after some time firms plan additions to the stock of capital long run. In this way, a longer horizon or long run may be viewed as merely a collection of many short run situations. Next is some examples of production functions. There can be varied forms of production functions. Some examples are the following. A simple linear production function Q is equal to A star L. B, a production function with diminishing returns Q is equal to A star LB, where 0 greater than B greater than 1. C, a production function with multiple factors, for example, Cobb-Douglas production function Q is equal to A star LB star KC, where 0 is greater than B greater than 1, 0 greater than C greater than 1. D, fixed proportion production function Q is the minimum of L and K. E, perfect substitutes production function Q is equal to A star L plus B star K. Next is production with a single variable input. The short run production function with one fixed input K and one variable input L is given by Q is a function of L K star. With fixed capital K star, firms change only labor in order to change its output. Now, we will define certain important concepts related to features of production functions in order to complete our short run analysis. Next is total product. Total physical product or total product TP is defined as the total quantity of output Q that a firm produces with a given amount of labor. In the short run, given the amount of capital K, total physical product is the maximum output produced corresponding to different levels of labor employed. From table 1, we can see 2 units of labor combined with 5 units of capital can produce a maximum of 224 units of output. Similarly, 3 units of labor combined with 5 units of capital would give 342 units of output. We see that at 0 units of capital, no output is produced regardless of the level of labor employed. In the same way, with 0 units of labor, a firm cannot produce any output irrespective of the level of capital employed. As we mentioned at the outset, in the short run, capital is fixed and output varies as labor units vary. Suppose we assume that the capital stock is fixed at 2 units in the short run, then if labor units are increased, output also increases. Using table 1 once again, we see that with capital fixed at 2 units with 1 unit of labor, maximum output possible is 52 units. With 2 units of labor, output goes up to 112 and so on. Output keeps increasing with increase in labor employed till a certain level of labor units. Thereafter, a stage comes when total output eventually falls as more labor is employed. This is shown in table 2 and the total product curve is graphically shown in figure 1. Table 2 shows the total physical product in the short run and figure 1 shows total physical product. Next is average product. Average physical product or average product AP is the total product Q divided by the number of workers. AP is equal to Q upon L. Graphically, it is derived by drawing a line segment from the origin to very point on the total product curve. The slope of that line segment gives average product of labor. Looking at figure 1, we observe that initially the curve is rising, becomes steeper, but eventually becomes flatter as units of labor employed increases. Hence, the slope of the line segment from the origin to the total product curve that denotes average productivity of labor shows an initial increase and falls thereafter as units of labor increase. Therefore, AP first rises, reaches a maximum and declines thereafter. In table 2, we can see the same trend, viz. That AP rises and then eventually falls. Next is marginal product. Marginal physical product or marginal product MP is the additional output produced by employing one additional unit of the variable input, that is L, with all other inputs remaining fixed. In this case, K is equal to 2. This means MP is equal to delta Q upon delta L, where delta means change. In this situation with one variable input, we refer to this as the marginal product of labor as we assume that labor is the only variable input. The above equation shows that MP is the slope of the total output curve, that is TP curve. The concept of MP can also be understood from table 2. We see that with 0 workers, the output produced is 0 units. When one labor is employed, total output increases to 52 units. This implies the marginal product of the first worker is 52 units. When the second unit of labor is employed, output increases to 112. This means the additional output due to one more unit of labor is higher at 60 units. 112 minus 52 is equal to 60 units. But as labor input is increased further, the additional output obtained eventually starts reducing. That is, the contribution of the additional labor units reduces. This is because capital is fixed at 2 units. So, marginal productivity of labor goes down as more and more of labor is employed with a fixed amount of capital. After a point, the MP becomes 0 and eventually negative, which means with the level of capital remaining fixed, employing additional labor will actually reduce output beyond a point. Note that here we talk about marginal product of labor and not of a laborer. It is also assumed that all workers are the same. That is, if we decrease 3 units of labor, we are not affected by which 3 units are removed from production. Next is the graphical representation of total product, marginal product and average product. We now examine the graphical representation of the 3 concepts, viz. Total product, average product and marginal product. In what follows, we use a particular functional form of a production function and calculate TP, AP and MP. We assume that the production function is given by TP is equal to Q is equal to F is a function of L and K star is equal to 60 L2 minus L3. We characterize the TP curve, the production function, by examining its shape for different levels of labor employed. We obtain the level of L for which TP reaches a maximum and examine its shape as L is increased further beyond this level. The results are summarized in the top panel of table 3, while the graph of the TP curve or the production function appears on the top panel of figure 3. Thereafter, we examine the behavior of MP of labor MPL as L is increased. Recall, MPL defined as delta Q upon delta L is calculated from the first differential of the given production function with respect to L. That is, MP is equal to delta Q upon delta L is equal to 120L minus 3L square. The shape of the MPL curve is plotted in the middle panel of figure 3, while the characteristics of MPL for different level of labor employed is presented in the middle panel of table 3. Finally, we study the behavior of Ap of labor APL as L increases. Recall, APL is defined as TP upon L or Q upon L. That is, APL is equal to Q upon L is equal to 60L minus L square. Its values are calculated for the given production function for different levels of L employed and presented in the last panel of table 3. The graphical representation of the APL curve is given in the last panel of figure 3. Differentiating and using the first order and second order conditions, we get the shape of TP, MPL and APL. Table 3 gives you the schedule with details on the relation between TP, MP and AP and the variable input L. In the first column you have labor, which is your variable input, then TPQ. In the last column it is the shape, max, minimum points. Figure 3 gives you the graphical representation of total product, average product and marginal product. Next we will discuss upon the law of diminishing marginal product. The law of diminishing marginal product is a very important principle which says that as the number of units of a variable input is increased, holding the level of all other inputs, example fixed input constant, a point will be reached beyond which the marginal product of the variable unit will start decreasing. The slope of the marginal product MPL curve as shown in figure 3 illustrates this principle. The reason this law holds is as follows. When the amount of the variable input is small relative to the fixed input, as more of it is employed, this results in more intensive utilization of the fixed inputs, resulting in an increase in the marginal product of the variable input. However, as more and more of the variable input is employed in due course, there is too much of the variable input in comparison to the fixed input. So that increasing the variable input yields progressively lower amounts of additional output. Consider the following example demonstrating this principle. A man baking bread output has a single oven fixed input. Working alone, he is able to produce 15 loaves of bread per hour. He adds a second worker variable input and together they bake 35 loaves in an hour. Hence, the MPL of the second worker is 20 units of bread per hour. When he adds the third worker, it results in 50 units of bread in an hour. So, the MPL is 15 additional units per hour. Therefore, after the second worker, the MPL of an additional man begins to decline. If he brings a fourth worker, total output increases to 60 units. We see that now MPL has declined to just 10 units. Similarly, adding a fifth worker leads to 65 units of output, hence adding just 5 units to the total output. Clearly, as the equipment in the kitchen is fixed, therefore, marginal contribution of additional workers is diminishing. Eventually, a stage comes when adding a new worker results in no extra output, which means his marginal contribution is 0. In other words, MPL is 0 at this level of employment. In fact, MPL of an additional worker can even become negative. For example, adding a sixth new cook would reduce output from 65 back to 60 again. So, the MPL is now negative, -5, clearly a case of too many cooks. Note carefully that negative MPL is different from diminishing MPL. In the above example, diminishing marginal product sets in with the third labor, but marginal product does not become negative until the sixth worker is hired. This principle helps us to understand the shapes of the TP and MPL curves, which are further discussed in the next module. Summary. The production function gives the maximum amount of output that can be produced from any given combination of inputs given the state of technology. Economic efficiency occurs when a given output is being produced at the lowest possible total cost. In the short run, at least one input is fixed. Typically, we consider labor L as a variable input, whereas capital K is a fixed input. In the long run, all inputs are variable. Average product is total output divided by the number of units of a variable input. Marginal product is the additional output attributable to using one additional unit of a variable input. The law of diminishing marginal product states that as the number of units of a variable input increases, holding all other input constant, there comes a point beyond which the marginal product of the variable input declines.